Welcome back to The Explainer. So imagine for a second that you're a researcher about to embark on just a massive, unprecedented quest. Your frontier? The entire cosmos. And your primary vessel is the imminent Nancy Grace Roman Space Telescope. Today we're going to open up the Ultimate Heroes Toolkit and check out literally everything you need to prepare a successful Cycle 1 proposal. We're talking everything from data access to simulated galaxies. Okay, let's get ready for this journey. Right off the bat, let's dive into this, because Roman's data access model is, well, it's completely revolutionary. You know how in the past, astronomers usually got this exclusive window to analyze the data they requested? Yeah, not anymore. Roman is totally shattering that traditional mold. There is zero proprietary period. The absolute second that data finishes processing and hits the archive, it belongs to you, to me, and to the entire scientific community to access and analyze. No waiting around. And just how much data are we actually talking about here? Well, a staggering 75% of Roman's nominal 5-year mission is already dedicated to community-defined surveys. So that means there's a massive treasure trove of observational data just sitting there, waiting for you to analyze it. You don't necessarily have to win some hyper-competitive telescope observation time to do groundbreaking science anymore. You really just need to propose brilliant ways to analyze the petabytes of data that are already on the schedule. To get you fully equipped, here's our roadmap for today. 1. The open universe. 2. The project infrastructure teams. 3. Calculating your exposure time. 4. Proposing with APT. 5. Simulating the cosmos. And 6. The Roman Research Nexus. Let's make sure your Cycle 1 proposals hit the mark. Section 1. The open universe, a new era of accessibility. Roman fundamentally transforms how we access astronomical data. With that 75% chunk going straight to predefined core surveys, think the High-Latitude Wide-Area Survey or the Galactic Bulge Time-Domain Survey, opportunities for new observation proposals are actually going to be strictly limited. General investigator new observations, highly competitive. So writing proposals specifically to analyze the data cascading from those core surveys is absolutely essential for the community. The data is the prize here, and it's completely open to everyone. Section 2. The project infrastructure teams, building the groundwork for science. Now, the good news is you aren't stepping into this new universe alone. NASA has selected specific project infrastructure teams, affectionately called PITs, to do a lot of the heavy lifting for you. These teams are tirelessly building the software, the simulations, and the data pipelines that are going to enable your research. Whether we're talking about the High-Latitude Imaging Survey, focusing on weak gravitational lensing, the Galaxy Redshift Survey going after baryon acoustic oscillations, or the Supernova Cosmology team. Their shared ultimate goal is to give you the infrastructure you need to put firm constraints on dark energy and cosmic expansion. Of course, timing is everything, right? So let's look at exactly when this critical weak lensing and galaxy clustering data will hit your desks. Right now, we're in the pre-launch simulation phase. Looking ahead, an early data release of the Cosmos Deep Tier in 3 bands is expected by July 2027, and then the massive data release 1 of all Deep Tier data is targeted for February 2028, which means you can actually start structuring your research plans today. Section 3. Calculating your exposure time. Can Roman see your target? Okay, the very first critical piece of software in your toolkit is the Exposure Time Calculator, or ETC. This is actually powered by the exact same robust Pangaea engine used for the James Webb Space Telescope. It's your absolute essential weapon for figuring out if, say, that incredibly faint 21st magnitude galaxy is actually detectable by Roman. It calculates your signal-to-noise ratio, and crucially, it catches those common proposal-ruining pitfalls. You know, things like oversaturating your detector before the ramp finishes, or maybe inadvertently setting your background annulus in a radius smaller than your extraction aperture. It saves you from all of that. And using the ETC is incredibly intuitive once you get the hang of the 4-step workflow. First step, instrument setup, where you pick your filters or dispersers, like the GRISM. Second is detector setup, where you define your multi-accumulation or MA tables that dictates exactly how reads are grouped. Third is your scene or source, where you can easily drop in predefined galaxies or even upload your own custom spectra. And finally, strategy, where you dictate your extraction apertures. You just feed your inputs through these steps and watch your saturation maps and beautiful signal-to-noise plots render right out the other side. Section 4. Proposing with APT, scheduling cosmic discoveries. So once you know Roman can actually see your target, you need a way to schedule it. That's exactly where the Astronomer's Proposal Tool, or APT, comes in. Now, if you've proposed for Hubble or Webb in the past, that name probably rings a bell. But because Roman is fundamentally a wide-field survey telescope, the APT required a massive architectural overhaul. You'll submit your completed files here directly to the Roman Telescope Proposal System, or RTPS, to finally get those Cycle 1 observations on the books. This overhaul brilliantly illustrates how the APT has evolved for Roman's wide-field capabilities. You're not just pointing at single fixed stars anymore. Now you can define custom region targets using polygons, literally drawing a shape in the Aladdin Sky Atlas and importing the coordinates. You can craft custom mosaic patterns with highly specific column and row overlaps to cover detector gaps. You can even group these massive sweeps into pass plans and apply special timing or orientation constraints. It's an incredible way to track down complex scheduling conflicts long before you ever hit submit. Section 5. Simulating the cosmos. Practice before you launch. Now, what if I told you that you didn't have to wait for the telescope to launch to start doing science? You can actually begin practicing your analysis pipeline today using incredibly accurate mock datasets, like the Gaia catalog for astrometry and the Open Universe simulations. Tools like Roman ISM output data perfectly mimicking the official processing levels. Level 1 provides uncalibrated science ramps, where you can see individual reads group into resultants as charge builds. Level 2 gives you the calibrated images. Level 3 combines those into massive mosaics, and Level 4 hands you the final extracted source catalogs. And just to appreciate how advanced these pipelines and simulations really are, consider this highly specific technical detail. For wide-field spectroscopy, the pipeline guarantees rigorous data products by solving the flux calibration matrix for each wavelength completely separately. This ensures pristine accuracy across the enormous field of view. What that means is the simulated data you practice on today is going to perfectly mirror the real cosmos tomorrow. Section 6. The Roman Research Nexus, the ultimate engine. Now, what's really interesting here is, well, we've talked about a lot of processing-heavy software, right? To ensure your local laptop doesn't literally melt down, Roman is introducing a profound paradigm shift. The old way of doing things was sluggish, downloading petabytes of data and reference files locally, struggling with broken Python environments, hitting hard drive limits. It was a mess. The Nexus method completely changes the game. It's a seamless, collaborative, cloud-based environment running on AWS S3 buckets. All the simulation tools, the ETC Pangaea engine, the calibration files, they are all pre-configured and pip-installed in Jupyter Notebooks right in your browser. So, my fellow researchers, the time to prepare is absolutely right now. The Cycle 1 call is here. Your toolkit, from the Open Universe datasets and the PITS infrastructure, all the way to the ETC, the APT, and that cloud-powered Nexus, is primed and ready. The cosmos is waiting. It's completely open with absolutely no proprietary delays. So, what will you discover in Cycle 1? Get into those tools, start building those proposals, and let's unlock the universe. Thanks for joining me on this explainer. See you next time.